I'll discuss only numerical based on RC circuit, current, electricity, magnetism, and EMI. Right. So now, students, without wasting time here, I'm going to start numerical based on first beta. I'll take here RC circuit. First student, I'll start RC circuit. Right. So in the RC circuit here, basic point just I wanted to discuss with everyone. It's a highly required beta and most expected here. Yes, student, it's the most expected also. So I can say, listen carefully, class. You will get everything. Right, my dear. Okay. So in RC circuit, so now student, I'm going to start numerical based on RC circuit. This is first Jai Shri Shyam. Right. Okay. So this is the first numerical for today class. Have a look. Student, this is the, let us say, circuit. There is capacitor. Capacitance beta, you can take, this is 5 microfarad. There is switch. Initially beta, you can take in consideration switch open. There is resistor and 6 ohm is a resistance of this resistor. There is one more resistor is here. What's that I have to take? Let's say, student, this is the battery and potential of this battery, I'm considering this is 10 volt. Student, this is the 4 ohm. This is 4 ohm, 6 ohm beta, this is a 5 microfarad, and this is 10 volt. Switch initially open. Switch, my dear, it's what? Initially opened. Right? Okay. Students, entire circuit I'm going to connect. Yes, beta. Now, let us see, student, this is the 6 ohm. This is 20 volt. What you need to find, my dear, in these questions? Find charge on 5 microcoulomb as a function of time t. Initially beta, just taking consideration, this is the data. What you need to find, a student? Find the charge. Find the charge on 5 microfarad as a student, as a function of time t. As a function of time t. S beta, I'll revise the student. I'll revise the formula with the help of numerical, right? So that's why this is the first numerical. I'm going to find charge as a function of time t. So just I can say, stay in live session, student. You will get everything on RC circuit. Yes, beta. Stay in live session. So this is the condition, student. We wish to find what? Charge as a function of time t on what? 5 microcoulomb, 5 microfarad capacitors. Okay. Let us say, students, this is a diagram for the questions. Now I'm going to solve these questions, my dear. Right. Student, now I'm going to solve. Okay. In the solution, step 1 beta. In step 1, here I'm considering this is what? T is equal to 0. T is equal to 0, students. If switch is closed, t is equals to 0 if switch is closed, right? If switch closed here, then have a look. I hope here all of everyone has a basic idea, because if time 0, beta, then current is maximum. Current is what, my dear? Maximum, right? And beta charge on capacitor, what we can say? 0. But according to time interval, you can say capacitor slowly started charging. Jai Sri Sam, student, right? So this is what, my dear? It's a 6 ohm. Now this is circuit beta. This I'm drawing because time 0 we have to find charge as a function of time t on capacitor. So this is 6 ohm, student. This is 20 volt according to questions. This is remains 6 ohm, student. Okay, fine. This is 4 ohm beta, and this is chain ohm. This is 10 volt here. It's a potential, it's not ohm. 10 volt. This is 4 ohm. Let us say, student, I'm considering here there are 2 points near about the capacitor. This is what, my dear? It's a point A, and this is point B. It's a point A, my dear. This is what? Point B, right? Okay. So here, student, I hope all of you remember here. At time is equals to what, beta? Just you close the switch. Then what you can say for this condition? This condition beta, you can analyze. So this capacitor act as an open circuit. Student, in the step 2, again I am going to draw. Again I am drawing one more circuit. Just time 0. Just time 0. So this is what, students? Capacitor act as an open circuit. Capacitor act as an open circuit, my dear. This is 6 ohm. Yes. So this is what, student? 4 ohm, and this is the potential, which is 10 volt. Okay. This is 4 ohm, student. This is 6. This is 6. So let us say, as I beta mentioned, this is point A and B. This is point by student A and B, right? So first I'll find what is the R equivalent across AB. This is 10 volt. This is 20 volt. So R equivalent, 6 and 6 beta, what we can see? Parallel. 6 and 6 beta, what we can see? Parallel, right? Because current will flow beta in this circuit. I hope all of you getting my point. Student, current will flow in this circuit only, right? So student, you can say what's a beta? We have to first find R equivalent. So this is 6 and this 6 in parallel beta. 6 6 are 36 by 12. 3 plus 4 7 beta. So you can write R equivalent student across AV, which is nothing but it's a 7 ohm. I hope all of you agree. I hope all of you agree. R equivalent what, my dear? This is what? 7 ohm. Okay, fine. Now students, I'm going to apply a KVL for a loop, right? KVL for a loop beta from here. In step 3 beta, I'm going to apply KVL. I'll solve here only. In step 3 beta, I'm going to apply KVL for this loop. So this is beta potential at A, it's a higher potential. So I'm calling this is VA. This is what? VA beta. Plus to minus, minus, plus to minus, minus beta. I hope all of you know about sign convention. This is minus 10 beta. Okay, and this is what? Current beta moving from here, because I'm applying loop law from here only. So this is beta what? 6. So what is the potential drop over here? You can write potential drop over here. This is what, my dear? V is equals to IR. V is equals to IR beta. So I beta, how much we can get here? Can we get? Yes. I beta we can write here. This is what beta is? I beta, what we can say, it's a 20, because for this loop beta it's a potential beta 20, and what's the R equivalent, 6 plus 6 in series for this loop. So this is what you can say beta 5 by 3. I student, finally you will get this is 5 by 3 ampere. This is what, my dear, I is equals to 5 by 3 ampere, right? Okay, so beta I'll use here V is equals to IR, so 6 into 5 by 3, which is equals to beta VB, which is equals to VB, my dear. So finally I can write VA minus VB beta 3 to the 6 here, so this is what, 20 volt. VA minus VB beta, I got this is a potential difference I got across the capacitor, which is nothing but it's a 20 volt. It's a 20 volt. We wish to find here Q as a function of T. We wish to find what, my dear, Q as a function of T. So now student, I'm going to use the formula here, charge as a function of time T. Student, now I'm going to use the formula, charge as a function of time T. Q is equals to CV 1 minus e to the power minus T by RC. I hope you are all of you remember. Someone requested, so beta stay in live session bacha, I will get everything, my dear, right? So this is Q beta. V beta we just now we found. How much beta? You can take a snapshot. Yes beta, you can take snapshot beta. Okay, so we got here V from here 20 volt, and what's the beta capacitance of capacitor, which is equals to 5 farad beta, right? So student, I can write, my dear, this is 5 farad beta, so 5 into beta, simply you can write 20, answer will get in microcoulomb here. This is 1 minus e to the power minus T, and R and C beta, what is R here, what's the R equivalent we got, 7 bacha party. R equivalent beta will got near across the resistor, R equivalent beta we got near, I can say across AV, this is 7 bacha party, so you can say 7 into what beta ji, this is what, my dear, e to the power beta is 7 into 5 in microcoulomb. So finally you can write as answer, student, this is 100, 1 minus e to the power minus T by 35 microcoulomb. So this is answer, my dear, Q as a function of time T. This is answer, my dear, Q as a function of time T. Okay, right? Jai Shri Sam, student. Very good. Okay. Yes, beta. Now yeah, just have a look. Next question is RC circuit. I'll do next question, my dear. Right. So have a look, beta. Next question. So what's the question, student? Next year. Next question, beta. Initially, let us suppose, beta, in the circuit shown in the figure, the capacitor is partially charged. Capacitor is partially charged, beta. There is initial charge on capacitor Q naught. You can write CV by 2 and T0, and student, T0, switch is closed. T0 beta, switch is closed, right? So find charge on capacitor as a function of time T. Same question. Find Q as a function of time T. Yes beta. So what's the questions here? Have a look, everyone. Now this is the capacitor, student. This is the capacitor. There is a potential difference. Initially beta, let us suppose I'm considering it's open circuit, right? Right beta. And just I can see initially there is a charge on capacitor. Students, initially charge you can take, that is mentioned, CV by 2, one side plus, beta one side we can take minus, right student? Let us suppose once you will close the switch, at t is equal to 0, so charge beta started decreasing. Let us suppose I am calling this is plus q, student, this is minus q, this is what, minus q, right? So student, first I'll write here, I can say first I'll apply KVL for this loop, KVL for this loop. So beta minus 2 plus, so now I'm applying KVL. So what beta, this is minus 2 plus here plus V, and what's the potential drop on capacitor? V is equals to Q by C. V is equals to Q by C, right student? Minus here you can say this is IR, which is equals to 0, So finally beta, just you can write here CV minus Q upon C is equals to IR. So I beta I can write here CV minus Q upon RC. CV minus Q upon RC. I beta I can write here I instantaneous student. So I student I can write it's dq by dt. This is CV minus Q upon RC. Student, now I'm going to apply, that is what my dear, concept of variable separable. Now student, I'm going to apply concept of variable separable. So what is this concept, student? You can say very easily, sir, this dq together, and only just keep identical terms together. Student, keep identical terms together only. So beta take snapshot here. Yes, I wanted to turn the page, means I wanted to just continue this system, but I'll not do here, I'll do next paper. Okay, so now students, here just go through this. This is what made here dq by dt, which is equals to CV minus Q upon RC beta. I'm going to apply a concept of variable separable. So this is dq, students, CV minus Q is equals to dt upon RC. Student, apply the limit here. Apply the limit, students. Time 0. So what's the charge on capacitor? It's CV by 2. If time becomes t, students, let us see charge on capacitor, which is equals to Q, my dear. Okay, so I hope all of you remember here, otherwise I'm repeating the formula. It's a very helpful, my dear. Integration of dx upon ax minus b. So you can, beta, what's the trick here? Just remember coefficient of x, student, you can just keep it out. So this is 1 upon a. This term will come as it is. So this is what, my dear? Ln of ax minus b. So student, I'll apply here. What's the variable here? Q. So minus 1 should come out. And this is ln of CV minus Q. Students, this is as usual, you can write T upon RC. So student, just don't forget to apply the limit. This is CV by 2 and this is Q, student. How can you apply the limit here? All of you very smart to apply limit. So this Q beta and this beta Q just replace like this. So minus 1 beta just in this side. So you can say ln, this is CV minus Q. Upper limit minus a student, lower limit. So this is ln CV minus CV by 2 is equals to beta minus T by RC. So this is, students, CV minus Q minus beta ln of CV by 2. This is what, my dear? T by RC. RC, T by RC, right? Just do it up. Do it up further. Do further beta. Okay. So beta, this there again you can apply the limit beta. But with you, very easy, sir. Student, God bless you. May I know beta, who are you and from where are you watching? May I know beta, you are from? Sir, how put patiently you explain? Yes, no, this is the meaning, student. Only live session here. This is the meaning here because everyone testing on YouTube. Something different, beta. I will get here at pages point only. Right, I'm trying here. Why I'm just started to teach on YouTube? Because now here I'm looking. It's need to teach in a, I can say, smooth and slow way, so that it can easy and everyone can learn the things. Okay, beta here I can apply student, that is ln m minus n formula here. So this is ln beta cv minus q upon beta this is cv by 2 is equals to beta minus t by rc. Just beta, take antilog both side my dear. Take a student antilog both side here. Right. So what you can write beta finally here? Student, you can write finally CV minus Q upon CV by 2 e to the power minus T by RC. Minus T by RC. This time beta, just change here this side. So student, take snapshot here. I wanted to just continue on next slide, this next page. Okay, I hope you have taken everyone's SS. Okay, fine. Now student, this is CV minus Q upon a student CV by 2 e to the power minus T by RC, my dear. So CV minus Q CV by 2 e to the power minus T by RC beta. T by RC student. We wish to find Q here, so we can say this is minus Q is equals to minus CV plus CV by 2 e to the power beta minus T by RC. Minus, take it common here. So we can say Q is equals to what beta? CV 1 minus 1 by 2 e to the power minus T by RC. So this is answer for this question. Q as a function of time t. Q as what, my dear? Function of time t. Right. Okay, very nice. I'm very happy to see it all of you. I can say your compliment. Just in the night, I can see time around 11:07, and all of you watching stream live stream of Facebook Beta. I'm feeling proud to see all of you. Wish you all the best for your future endeavor. Now student, have a look at next question, everyone. Okay, so what's the next question, student? Here student, you have to find, that is find the steady state charge. Find the steady state charge on both capacitors. Both capacitors. long time. This is long time after closing the switch. After closing the switch, yes, right beta. Okay. So now I'm going to show in circuit diagram. So this is my dear 1 ohm. There is one capacitor, capacitance 4 microfarad. You can take this is I can see along with the capacitor there is a resistor. You can take beta 6 ohm is the resistor. This is 4 beta the microfarad. There is one more capacitor is there, student. This one also connected through a resistor, right? And entire setup student, just let us suppose I'm connected through battery, and initially beta let us take in consideration switch open, but we have to find if switch closed for long time. Student, we have to find switch closed for long time. Student, if we have to find here, I can say if we'll close a switch for long time, then we have to find charge on all, both of the capacitor beta. One beta I can take 4 microfarad. This one beta I can take 2 microfarad. Beta yes, data I can take. This is 20 volt. This is 20 volt. Now beta, this is what switch closed. This is what, my dear, switch closed, right? Okay, you can take care. This is 2 ohm. This is 1 ohm. No, what is the logic beta for this question here? Someone said, sir, repeat, just revise the formula. But I don't know. No, student, if I'll revise the formula here, that is not much effective. But if I'll explain the concept come numerical, then that is durable and more understandable for you also, right? So student, have a look at the things. Student, what is the concept here? For what's the clear concept for these questions? Student, in solution. Student, in solution. This is step 1. This is step 1. Student, for long time or steady state. Long time steady state, what you can say, bacha, capacitor act as a what? Open circuit. Beta, if time 0 beta, then you can say this is what? Capacitor acts as a plain wire. If time is equals to infinity, then beta capacitor acts as an open circuit. This is what, my dear? This is the concept here. Just keep in mind. If time infinity, then it will act as an open circuit. If time 0, then capacitor act as a plain wire. This is a point beta which you can keep in your mind. Now student, further here we'll go through this again. Beta, in step 2 I'll redraw the circuit. Because it's open here. It's if beta, you can say if this is open circuit, so there is no any contribution of flow of current in this circuit, because I hope all of you has a basic idea. Flow of current in the circuit, current must be closed, right? So this is 20 volt, and beta, now we are just, let us suppose you can take switch is closed, and there is one more beta resistor S beta. This is the condition, just take in your mind. Yes, sir. Okay, so this is what, my dear? 1 ohm. This is what, student? What I have to take? Let us suppose this is 4 ohm. This is 4 plus 1. So this is 4 ohm. 1. This is 1 ohm beta. This one, I can say beta 6 ohm and 2 ohm act as a beta. I can circuit, right? Which is open circuit beta. This is beta G 20 volt. Now you can see simply, student, there is no any contribution in this circuit. So simply beta you have to find current. So what is current here? You can say V upon beta G R equivalent. So what is V, my dear? It's 20. It's a 20 and R beta 4 plus 1, this is the 5. So current beta will get 5 for 20 here. So this is what, my dear? This is the 4 ampere. This is the 4 ampere. Now beta we wish to find basically charge on this capacitor. So beta for getting charge on this capacitor we must find what's the potential difference. So student, have a look. I can see step 3, student. I'll try to finish on this page only, right? So here beta, this is S3 here. Beta we have to find here what is the potential drop here. Aryan, hello. Oh, Aryan, how are you beta? Arre wah, good. Aryan bacha, congratulations. Literally Aryan beta, your physics score literally very good. Good. Overall 97.23. Congratulations beta, I'm very happy to see your result. Okay, Aryan beta, what about your like say beta your today test paper of 12th class physics? Paper was not tough, quite I can say, student. Uh, hmm. Few questions I can say beta little lengthy. Now this time I will do I can say beta with respect to January attempt very much good here. Yes, you will do it. You have potential. Yes. Okay, so have look beta, very happy to see Aryan bacha your score. Now we are so beta here we have to find the student what is the potential drop. Yes beta, it's moderate, correct. So beta, what's the drop over here bacha? So you can apply beta V is equals to IR. So I beta 4 here and this is 1 ohm. So you can say bacha V is equals to 4 volt. So now beta you can see this is the potential drop will come as usual here also 4 volt and bacha G here also 4 volt. Why? Because these all are in series parallel. These all are in parallel here. So simply beta now I'm going to find charge on 4 microfarad capacitor. So this is Q is equals to I'll use CV. So C beta G, this is you can say 4 into 4. So I'll get 16 microcoulomb. Next beta again I'll apply here Q is equals to CV. C beta how much? 2 into 4. So this is what, student? 8 microcoulomb. This is what, student? 8 microcoulomb. Okay, fine. Now student just will go through this here. It's not a tough at all beta, right? Literally it's not a tough at all, right? But this kind of variety of the questions asked in JEE means multiple time, and there is a very high probability they can repeat same questions. They can repeat same question, student. Okay, so student again here have a look next question. Data take snapshot. Right. So student finally in this question again we have to find the first I'll make a circuit diagram, student, then I'll tell my dear, right? What's the thing with the circuit diagram? I'll make first. This is yes beta, God bless you for reaction, student. This is 3 microfarad. This is 5 ohm. How can I take data here? Circuit I remember, data I have to think here. Just give me some time. Yes. Yes beta, this is circuit here, right my dear. Then beta I can say take 10 ohm, this is 5 ohm. Student, I can take 10, 20. This is 10 you can take. Yes, fine. Find charge on, this is you can take 5 beta. Find charge on 3 macrofarad capacitor. Right. Have a look beta ji. How can we do this question here? Right. Go beta slowly here. Okay. So speed. I'll apply a KVL 2 times because you know this is a circuit not I can say useful for us. Why? Again beta I'll read through the circuit here because initially beta we'll take your consideration for T0. I hope all of you remember T0 capacitor act as an open circuit, right? So I'll again here make little fast. This is circuit useful for us beta. In fact, I can say this will act as an open circuit. This will act as an open circuit beta. This is the 5 and one complete circuit, this one 5 ohm. Oh, what I have to take care of this potential. This is 2010 5 5 5. You can take with this one also 20 here. This one also 20 bits. So this is 20 student. You can take with this is 10 5 5. As usual I have taken 10. This is 20. This is 5. Right. So here I'll apply it because this is open circuit, so we can't apply KVL. So first of all I'll apply KVL over here for this loop. Let us say current is I1. Next I'll apply KVL for this loop here. Let us say this current is I2. This current is what my dear? I2, right? Okay, so come to the point my dear. KVL beta I'll apply first for this loop. So in step beta 1 I return the circuit here. In step 2 beta I'm going to apply KVL for loop 1 for you can say beta loop anything here, you can say for loop I1. Yes beta, I'm applying KVL. So V is equals to IR. What beta we can see? V is equals to IR here. So this is current beta flowing in the circuit. Current beta flowing in the circuit here. So this is beta I can see 15 beta is I1 minus 10 I2. 10 beta is I2 is equals to 10 volt. 20 minus 10 10 volt. Okay, let us see beta. This is equations number 1. Or can we do cancelling each other? Can we do it cancelling each other here? Can we do cancel with party? 5 times here. 5 2 are 10, 5 2 are 10, 5 3 are 15 here. So this is 3 I1 minus 2 I2 which is equals to 2. Beta say equation number 1 my dear. Student say equation number 1. Okay, now student I'm going to apply a KVL for this loop. KVL for this loop. So listen beta carefully everything here. Yes. Now beta see, I can say in step 3 beta I'm going to apply KVL for this loop. KVL for this loop beta. So what's the current here? This is what? Minus 2 plus 20 I2. 20 I2 beta. Then beta what we can say? 5 and 5 here. It's a 10 bit, right? So beta 20 I2. 20 I2 minus 10 I1 which is equals to 20 beta. Again here you can see cancel each other. So what, my dear, this is 5 4 ja 20, 5 to 13 and 5 4 ja 20. So this is, student, you can write 5 4 ja, so 4i2 minus 2i1, which is equals to 4. Again here you can see 2 times cancel, 2 1 ja 2, 1 and 2. So this is beta, you can write 2i2 minus i1, which is equals to 2. Say equations number second. Finally beta, we can solve here. We have two equations, two unknown. So in step 4, student, I am going to solving student equation 1 and 2 here. So this is 3i1 minus 2i2 is equal to 2 beta. This is 2i2 minus i1 is equal to beta. Just simply add here. So you can say this is kopach 3 minus 2 beta. This is what we can say, 2i1 is equal to 4. So you can say beta i1 is equal to 2 ampere. Student, i1 is equal to service student C. I hope you got your answer. Beta, may I know from where are you watching stream life of physics point, and in which grade you are? Okay, I remember this is what, 2 ampere. Beta, once you will get I1, this value beta you can fit in any of the equations here. Let us say I'm just using beta equations number equations 2. So student, step 5, from step 5 student, this is using beta equation second. Then there is no reply for you. Okay, 11th class. Okay, 2i2 minus i1 is equal to 2. So this is 2i2 is equals to 2 plus i1 beta, and I went to 2 to the 4. So i2 beta you will get, that is also 2 ampere. I1 beta 2 ampere and I2 also, student, it's a 2 ampere, right? Okay. Now student, I can say that a KVL for A to B we can apply once. This is, student, let us suppose this is A and B. So if once I apply but KVL from here, so this is potential at A. This beta will go through this like this, just moving this format. So this is VA minus 2 plus VA plus 20 beta. What is current here? This is I2. So plus minus beta and minus VB. So step 6 here. Step 6 beta you can write. Just I'm applying again beta KVL for this because I wanted to find what is the potential of VA minus VB. So this is VA beta higher potential minus 2 plus. So in step 6 here, I'll continue further. Student, in step 6 here, this is VA minus plus 20 minus beta 5 into 2 minus VV is equals to 0. Student, minus VB is equals to 0, right? Okay, you can write here, this is which is VA minus VB which is equals to how much coming here? 5 to the 10. 5 to the 10. So this is what you can see here, minus 10 volt, or you can say VV minus VA is equals to 10 volt, right? So last bit I can write down is step 7, that is a charge. Student, this is charge on 3 microfarad capacitor. So this is Q is equals to CV. C beta is 3 and this is 10. So we can finally write 30 microfarad. So this is the student answer of these questions. Right. So it's not tough at all. These all things required, I can say, huge concentration and practice of numerical. Practice of numerical beta literally very much required for this pattern of questions. Right, my dear? One more bit last question on RC circuit. Student, one more last question on what, student? I can see on RC circuit, right? So this question bit little, I can say same, little changes only which questions remains same, we have to find charge. What's the questions you need to find? Find charge on 4 microfarad and 6 microfarad capacitor steady state, right? Okay, now I'm going to just draw circuit diagram. I'll try to make the data must be easy. Just wait. Yes, I'll try to make data easy. I don't know. I'm trying. Yes, beta. There is. Yes, I can make these questions. This question is not. It's look like. Yes, I can make question based on like beta. Current electricity. Means I can say I already drawn maximum numerical, multiple numerical kind of this, right? So this is you can take 4 microfarad. I'm trying to take easy data, I don't know. This is 2 microfarad. This is 3 ohm, 4 ohm, 6 microfarad, 5. Anything? Yes. I have to just close this circuit, student. Yes, fine. This is, students, I can take 4 ohm. Yes, I'm thinking that data is not correct now, so it's very tough to solve these questions. You can take, this is 6 to the 12, 8 for the 6, 24. Yes, solvable. You can do 5 ohm beta, and this is last one. 18 volt. Let's check data here. There is a potential difference 5 ohm, 6 volt. Okay, this one you can take 10 or 12. You can take beta 12 volt. You can take, this is a 12 volt. That's fine. Okay, come with that. So we have to solve these questions here, right? Okay, So we have to find charge on what? Capacitor beta. I can say this is 4 microfarad and 6 microfarad. So we must find potential drop across this. That is a question for the question. That is a, I can say things for these questions. Right. Okay. Come it. Come it, everyone here. Okay. So, beta ji, first we have to find your current, because you know time zero. Beta, what you can say? Time zero. This entire circuit, beta. This entire circuit act as a what? Open circuit. You can make diagram here once. You will make idea. Student in solution, right? For getting current here, you can draw diagram like this. This is 18 volt, no change. This is 4 ohm, there is no change. This is 5 ohm, there is no change. This is 12 volt, there is no change. This is 6. So this is 6, this is 4, this is 5, this is 18, and this is 12. Right, both are in same here, so you can simply add. So 18 plus 12 beta 30. So I, you can write, student, I is equals to V by R. So this is 30 by 15. I is equals to, this is 2 ampere. I is equals to what beta? You can write here, this is a 2 ampere, right? Then student, I'll apply here there in this low. First I'm applying nodal analysis, little students, right? So I'll apply a nodal analysis and solve further these questions. So what is student? How can we do? Yes. Yes, beta, move on. Next slide here. For nodal analysis. Next page here, not slide, it's a habit. Student, this is 18 volt. This is 18 volt. Beta, just forget here. I'm just trying, but there is no any such contribution of this circuit. This is beta 4 microfarad. I'll take beta this point as junction point. This is 2 microfarad beta, and this is 3 ohm. Right. Okay. Now students, this is the 4 ohm, 6 ohm beta. What I have taken the circuit? It's a 12 volt. This is 12 volt, and this is 6 ohm here. This is 6 ohm. So you can say beta 6 ohm here. This is 3. This is 2. This is 4. This is, remember here, this is a 4 microfarad. This is 6 microfarad. Yes, this circuit there is nothing. Only one, I can say, connecting wire, or you can say one wire. That is, students, this is mentioned 5 ohm, right? Student, this is 18 volt. This is 12 volt, right? You can say 18 volt here, and this is what you can say 12 volt, 6 ohm. Acha ji, this point here I have taken as a junction point, my dear. This point, student, I have taken as a what? Junction point, right? So student, if this is junction point, so beta from here to here, you know, there is no any contribution beta for this one initially. this one bit I can take here, it's 0. If this is 0 here, so we can easily say, we could easily say this is 18 volt, this is 18 volt. Beta ji, if this is 18 volt here, so this is 12 volt. What is a drop over here? So 18 volt bacha bati, right? This is 18 volt. So beta, this potential drop here, how much can I write? This is 20 volt. This is 20 volt. If this is 20 volt here and this is 12 volt, so here I can write beta ji, this is 8 volt. This is beta what I can see, 8 volt here. So beta, this I'm going to apply a nodal, I can say nodal equation at x from concept of nodal equation at x. This is what, my dear? 4x plus twice into x minus 8 plus 6 into x minus 8, which is equal to 0. So acha, what you can write beta ji, 4x and this is 2x, 6x and 6x beta ji. This is, or can I say here, 2 cancel each other. 2 2 are 4, 2 2 are 1 and 2 3 are 6 here. So we can say it's a 2x plus x minus 8. Beta, give me seconds here. 1. Yes. Yes, beta, I'm coming back. Just beta, do further here. Do further, student. Yes, my dear. Okay. So yeah, just solve further, student, this question. Okay, anyone? Did you solve? Okay. Did you solve, anyone? Okay, fine. Now here I'll do. Yes, beta. Come here, anyone here? Yes, student. So here, this is beta, can say 2x, x minus 8 plus beta. This is what? 3x minus 24 equals 0 here. 3 to the 5 plus 1, 6x. 6x beta, you can see 32. 6x beta is what you can see, this is what? 32. So beta, further you can write a student. This is 6x is equals to 32. X beta, you will get 16 by x is what you can write, 16 by 3 volt. X what is student, you can write 16 by 3 volt. Okay, once you will get x beta, so this is I can say 4 here only here. So you can say Q is what beta? CV. Q beta, what you can say? CV. So what will I said to find here? Find charge. Okay. So student, simply I'll use. So I can say charge on 4 microfarad. So Q is equals to CV. So 4 into beta. This is 16 by 3. So 64 by 3 microcoulomb. Next student, charge on beta 6 microfarad. So this is students Q is equals to again CV 6 beta Z. This is what 8 minus 16 by 3. So beta 8 3 the 24 here. 24 by 16 here 8 by 3 6. So this is what students 16 microcoulomb. So this is the answer for these questions. My dear, this is the answer for these questions, right? Okay, so this is all about beta which I have done till now based on beta only RC circuit. Now student, I'm going to use your few just I'm going to solve few numerical which is based on beta. I can say current electricity, which is based student I can say on current electricity, right? So initially student I'm just targeting here those points, those questions in which those questions have a more weightage in the examination hall. Right? So have a look at that because just now I applied your KVL case here. So I'm going to use I'm going to just solve a few numerical which is based on KVL and KCL only. Yes, beta. So what's the question, student? Yes, beta. First I'll make circuit. This is beta Z 2 ohm. You can take this is 2 to 4. There is one battery, student. There is a battery. This is what 20 volt. 4 ohm you can take. 2 beta 40. This is 2 2 no you can take 2 and 4. 2 and 4. But you need to find, let's say R is equals to 4. Find current in the circuit. Find the student current. You can say R1 resistor. Find current in student. Find current in R1 resistor. Okay, so it's easier. Easily you can do this question. Just application of KVL and KCL we have to think. Right, my dear? You can do easily this question there. There is no doubt at all. Yes, beta. So what's the question, student, for this condition here? Because if you are getting in the, what's the trick? What's the trick, student, to solve questions here in KCL and KVL? If you got a certain, if you are not able to configure either series or parallel, so beta for that conditions you have to apply your junction law. So let us see, student. This is the point here. I'm calling X. I'm calling X. If this is X here, so current will flow from here. So this is the junction point. Always you have to take as a higher potential. Student, junction point always you have to take as a higher potential. Give me seconds here. I wanted to switch on the fan. Yes, yeah. Okay. Hello, Samrit. Okay. So this is beta G 20 volt. Right, student? Okay. So this is X beta. So what you can say? This point potential. This is X minus 40. This is what my dear? X minus 40. Right? Okay. Then we'll go through this. Yes, student. So that's it. We continue here. X minus 40 student. Okay. So this is X here. So this and the potential. Let us suppose I'm calling 0. If this is 0, so minus 2 plus plus. Here beta also 20 volt. This point also I can see 20 volt. Right? Okay. So student, this go through here one KCL from here. So this is beta KCL. Applying beta ji KCL for X. Student, applying KCL for X. So this is what? X minus 0 upon 4. Current is what? I can write here. I is what? Delta V by R. So I beta I can say X by 4 plus X beta minus 20 by 2. X minus 20 by 2 plus beta G. X minus 4G. X minus 40 by 2. X minus 40. Because this is 0, this is 0 remains. Right beta. This is 20, this is remains 20 only. So X minus 40 by 2 plus beta last one. Beta this on this I can say current on this 4 ohm. X minus 40 minus 20 by 4 is equals to 0. Is equals to 0. Right. Further here just solve the take beta LCM. So this is 4 everywhere here. Just go through this ones. So this is X plus beta. This is 2X minus 40 plus beta. This is 2X minus 80. Beta this is remains same here. X minus 60 equals 0 beta. Entire 0. So what you can say? X, 2X, 3X, 2X, 5X and X 6 here. So you can say this is what 6 is equals to 40 and 80 beta. This is 120, 160 beta. So X you will get 160, 180 near. Just 180 only here. 180 student. 180. So X is 180 by 6. So X beta G you will get 30 volt. X student what you can say this is what basically 30 volt. Once you will get X here you can find a bacha this current here. So what is beta answer finally you can write here. So I for 4 ohm. So I is V by R. So this is X by 4 So 30 by 4, you can write, my dear, 7.5 ampere. You can write, student, this is what? 7.5 ampere. So this pattern of questions you must know, right? This pattern of questions you must know, because this is with standard questions. Yes, they can ask. They can ask with it. It's not a tough at all. It's not a tough at all. So we have to just make a grip of these kind of questions, because being a time, beta, they can ask your questions. They can ask these pattern of questions, right? Okay. Yes, beta. We'll go through here one more good question. Yes, current electricity. I can say, beta, this is a question here asked by multiple times by students. This is a question, beta, which I'm going to solve. This question asked by student multiple time, right? It's good questions. I can say not a good question. I mean to say it's a literally means there is a possibility in any competitive examination they can repeat. So what's the question here? Yes, it's basically been a question from your combination of cells, right? So this is, friends, EMF E1, resistor party R1. This is R1, student. Now connected to it, I can another circuit. This is R1, R2, R beta. This is still EMF, you can take E1, R1. This is what, my dear, E2, R2. Find the maximum thermal power. For this question, find the maximum thermal power. Find the maximum, student, thermal power, right? So have a look, Betaji. How can we do this question here? I hope all of you remember this question asked in this line only. In JEE, first time they asked beta this question. JEE asked this question in 2018. This year also they repeated. JEE 2026 January attempt beta. They repeated this question. Right? So what's the question, student? What's the question, student? What is the value of internal resistance for maximum power transfer? So what's the answer, student? I hope all of you remember it. For maximum power transfer, for maximum power transfer, students, you can write R is equals to R. I hope all of you remember. R is equals to, someone is wondered. Yes, beta, correct here. Okay, fine. So beta, first I'll find here R equivalent across AB. R equivalent across AB, beta. Right, you can take beta the points. This is A and this is B. So I can say for this beta resistor, these two are in parallel. These two are parallel, beta. Right. So I can write beta. This is R equivalent student across AB. This is R1 into R2 upon beta is R1 plus R2. R1 into R2 beta. What I can say R1 plus R2. Right. For maximum power transfer, which you can say these two are equal. These two are what you can say which are what equal here. So for maximum power transfer, let us, because it's R. So for maximum power transfer beta, I can write R1 into R2 upon beta is R1 plus R2. Beta, just keep in mind here this result I'll use later. Okay. So beta, here I'm going to find here, I can say potential difference across AB. Potential difference across AB beta. So this is what my dear, I hope all of you remember here, E1 upon R1 plus beta is E2 upon R2 upon beta 1 upon R1 plus 1 upon R2. It's a normal formula of combination of cells, my dear. It's a normal formula of combination of cells, my dear. Right. Okay. So come to the point. Beta. So finally beta, just you can solve further here. So you can just take LCM. This is what, my dear? You can say E1 R2 plus student A2 R1 upon beta R1 plus R2. Right. So we can write here maximum power transfer. We can write beta what? Maximum power transfer here. So student take snapshot here. That is the last part of this questions. Student. Okay. So beta for maximum power maximum, students, you can write potential of AB V upon R. I can say, you can say potential of AB. This is what, my dear? Formula I'll write here first. V P is what? V square. So this is beta, you can say potential of what is power? P beta, you can say I square R, and P beta, you can say V square by R. This is the formula which beta you can keep in your mind. P is equals to beta, you can write I square R beta, and P also you can write what? V square by R. So power maximum beta, I can write over here potential of AB upon beta, this is 2R whole square into RR. So I use beta, P is equals to what? I square R. I use beta this formula. Right? Okay. So bacha ji, here our maximum beta, what I can write? This is what, student? Potential of AB whole square upon beta is 4R, which is equals to E1 R2 plus E2 R1 entire beta is whole square upon beta 4 times of R1 R2 into R1 plus R2. So this is, I can say beta, answer of these questions. This is what my dear answer of this question. So these all are, I can say, kind of questions, just I selected here few questions to solve. So this is, I can say, one of the question here which already I solved, my dear. Right. Have a look at the next question here, everyone. That is the next question here. Literally easy, but conceptually strong. Student, what's the question here? Beta, I can say a long cylindrical wire of radius A, right, and uniformly charged. Okay, beta, I can take care. There is, I'll make here two part of the questions because it's very tough for me to just turn the page always, right? Yes, beta, we'll go through this. So, students, this is, we have a long cylindrical wire which is fully charged, which is what, my dear, fully charged is a long cylindrical wire. Student, it's long cylindrical wire, right? Okay, which is fully charged, beta. You can take a student. This is central axis of the cylindrical wire. Central axis of the cylindrical wire. So, student, this is the radius of the wire. This is what A you can take. You can take a little consideration. Then I'll see. This wire starts moving along the length at speed v. Okay, let us suppose this wire started motion in, I can say, along the conducting wire. Right. Find the convection current due to physical flow of charge. Later, we have to find, students, find convection current. Find convection current, right? Okay, so come everyone to the point here. Yes, beta, come to the point, everyone. Yes, beta. So, beta ji, I hope all of you remember here concept of beta equipotential surface. Student, I hope all of you remember concept of equipotential surface. So, student, what's the concept of equipotential surface here? It is the electric field lines. The electric field lines are always perpendicular to equipotential surface. So you can say freely. You can say freely. This is the electric field, which is equals to E. This is the electric field, which is equals to E. If a linear charge density of a wire, because it's a wire, so we can take beta. Charge density is what? Lambda 1. What was it about? Lambda 1 here. I hope all of you remember here because we wish to find current. So before finding current beta, first I'll write here expression of electric field. So what is electric field? Due to infinite charge wire, this is 2k lambda by d. So 2k lambda by what? A. 2k lambda by A. We can write this is 2k lambda by A. Right, my dear? Okay. Here, this here which I can further manipulate. Yes, beta. Electric field beta further manipulate. This is 2 1 lambda bit k. I'm writing a student 4 pi epsilon naught lambda 1 2 to cancel. So electric field you can write lambda upon 2 pi epsilon naught into A. Electric field what you can say lambda upon 2 pi epsilon naught into A. Right. So lambda here I can write from its linear charge density 2 pi epsilon naught E into A. This will be the lambda you can write here. Okay, charge flow any cross section in 1 second. charge flow beta in any cross section in 1 second here. So this is beta, you can write charge flow in 1 second. So this is I is equals to lambda into V. So lambda beta we already found 2 pi epsilon naught E into A into V. So so this is my dear answer of these questions here. Yes, yes my dear. Just move here on a next question student. Just move students next questions here. There is a very common moment of current which already I solved few questions here previously also, right? Okay. Yes beta, I hope you are all of you written, taken snapshot here. Now student, have a look at next question. Yes, what questions here? No beta, again here, I can say current and basically beta capacitor. Usually you can say beta RC circuit. RC circuit student, it's I can say here very common format and very you can also say my dear useful here, because RC circuit it's a concept highly important. So just kill the question on RC circuit. You must have a grip on I can say like both of the chapter, current also and capacitance also. If you are pretty confident in both of the chapter, then you can do the questions. If there is a little I can say doubt in any of this chapter, so literally beta it's very tough. Literally beta I can say it's very much tough here. Okay, so what's question student? We'll go through here. I'll write here these questions because it's I can say in this question student I'll use concept of leakage current. Student, in this question here I'll use concept of leakage current. I hope all of you knew and very much aware about I can say leakage current. If not, then wait, stay in live session. So this is students, I can say there is two metal spheres of radius of student radius A and B, of radius A and B are located student are located in a homogeneous poorly conducting medium with resistivity student with resistivity rho. Find the resistance between spheres if their separation is large compared to their radii, right? Okay, so come to the point, student, everyone. Beta, for this questions here, what's the solution? Initially, beta, I can see two smaller spheres A and B located at a homogeneous polarly conducting medium with a resistivity rho. Find the resistance between spheres if their separation is large compared to their radii. Okay, you can take beta, you can understand like this. This is sphere A. This is what, my dear? Sphere A. Right. This is sphere B. You can take beta. This is sphere B. This is sphere A beta. This is sphere B. And you can write, my dear, rho is what? Resistivity. Rho is beta what? Resistivity already means homogeneous polarity conducting medium with resistivity rho. Okay. Let us suppose you can understand like this, student. If we assume dielectric constant of medium is K, then capacitance of this system of two sphere is beta. I can write here what is the capacitance of spherical capacitor if I'm considering a dielectric medium between the capacitor, my dear. So this is what C is equals to K times 4 pi epsilon naught A into B upon beta G. A plus, this is what capacitance of beta spherical capacitor. Capacitance of what, my dear? Spherical capacitor here. Okay, for beta there is things here. I hope all of you remember it. Concept of, I can say, leakage current. So beta I'll use over here what's that is tau is equals to RC. What, student? Tau is equals to RC for resistor here, right? So this is tau is equals to, students, RC. This is rho K into epsilon naught. This is what beta? Rho K into epsilon naught. And I can get resistance from here only. This is rho K epsilon naught upon C. Rho K epsilon naught into C bacha. And C beta already be found from here. C beta already be found from here, students. So finally, you can write expression of resistance which we wish to find. So R beta, this is rho K epsilon naught, and this is K 4 pi epsilon naught into AB into beta G, A plus B. You can say this K cancelled, epsilon naught cancelled. So finally you can say rho into A plus B 4 pi AB, right? So this is the answer of this question, sir. Yes, beta. This is what is the answer of this question, sir. So this kind of questions, it's literally not tough at all. Not tough at all. But beta, I can say practice required here for this kind of questions. Right. Now, again here, I'm going to do one more questions, which is based on capacitor. Which is this one also here, you can say capacitor only which it's capacitor concept, in fact, which I solve the questions. Now beta just have a look of the next question, student. Okay, students, I can say we have to find equivalent, find the surface charge density on a charge appearing at the boundary of dielectric, right? You can see beta we have to find charges on dielectric. Student, here I'm considering this is a parallel plate capacitor. This is what? Parallel plate capacitor. Now student, this entire setup here connected to V volt battery. Beta, what we can say, this is V volt battery, right? Okay. Now students, I'm going to here, I can say place dielectric. So now I'm going to place dielectric with dielectric constants. You can say which K1. So you can say which this is dielectric constants K1. This is K2. You can take with this separation is D1. This is separation beta. You can take this is what D2. K1, K2 beta. And resistivity also mentioned here because we need to find what is the charge on dielectric. So you can also take resistivity, which is rho 1. This is a resistivity. This is what you can see. Rho 2. But what we need to find here? Find the surface charge density. Students, find the surface charge. Find the surface charge density of charges appearing charges appearing at the boundary of dielectrics. Find the surface charge density of charges. Find surface charge density of charges appearing at the boundary of dielectric, right? So we have to find charge, right, student? Have a look here of the questions in the solution part. Student, earlier I make two part so that I can solve questions on one paper only. It's also tough for you and me also, always turning the page. Okay, so come back. Beta Z, first I'll write here resistance between the plate. Solution. First I'm going to write resistance between the plates. What my dear? Resistance between the plates. So both are in series only here. You can easily say both are in series. So you can write beta R equivalent, which is equals to R1 plus R2, which is equals to R1 plus R2. I hope you remember your formula of R. R is what? Rho L by A. Rho L by A. Beta, you can take student. A is the area of cross section of plate. So this is what? R1 plus R2. So R equivalent R1 beta, what you can say? This is rho 1 L1 beta, this is G1, rho 1 D1 upon beta जी A plus beta rho 2 D2 upon A. Right, my dear? Okay. We have right here leakage current in capacitor. So I beta, what you can see, V upon R. Students, leakage current in capacitor. Leakage current in student capacitor here. So what student you can write I is equals to beta V by R already we found, or you can say I is equals to V upon R equivalent. So you can say V into beta, this will A goes up here. This is what my dear, rho 1 D1 plus rho 2 D2, rho 1 D1 plus beta. This is, you can say, rho 2 D2, right? Charge on plate, right? With this, you can just find here charge on plate. So charge beta, what we can say, Q is equals to CV. Q is equals to CV and V is equals to IR. V is equals to IR. No, okay. This beta will go through here. This beta. I'll make here one diagram so that you can easily understand. Yes, beta ji. So this is C1, this is C2 beta. This is C1, this is what my dear, C2. So this is beta G, C1. Now this is my dear C2. Entire setup beta connected through battery. Entire setup connected through battery which is C1, C2. This is V. This is I. C1 beta you can write plus Q1 minus Q1 plus Q and minus Q. Right. So here if I write minus Q, so let us suppose beta I'm considering here what this is X and this is what student Y, right? So charge on plate X and Y, charge on plate X and Y, beta charge on plate X and Y are beta, what I can write, this is minus Q beta on X, so minus Q1 is equals to beta CV. So this is K1 epsilon into A upon beta D CV दिया equals to CV and V beta, this is V into A, because we can write here V is equals to IR. So this is just now we found, this is rho 1 D1 plus rho 2 D2 and with what we can write here finally, what's the resistance initially, rho 1 into beta D1 upon A. Terms here, few terms you can say cancel each other. Which terms? Beta, this is D1, this is D1 finished, this A finished. So Q1 you can write beta G minus rho 1 K1 epsilon naught V into A upon beta G. This terms only here. So this is what, rho 1 D1 plus rho 2 d2 plus beta what you can say this is rho 2 d2. Okay, fine. So this year we got a charge on a plate X. Similarly, we can find charge on plate Y, which is equals to beta is Q2, which is what beta you can say Q2, right? Beta this is beta charge here. You can take this is plus Q minus Q, and this is plus Q2 and minus Q2. So again here I can write beta Q2 again same. Q is equals to what? CV. Q is equals to CV and V is equals to IR. V is equals to beta IR. So now I'm going to write an expression for Q2. Expression of beta. This is Q2 here, which is equals to CV, C beta, and V is equals to IR. Simply I will get. So what is C beta? K2 epsilon naught into A by beta is D2 into V into A. Just now you just derive everything bacha. Rho 1 D1 plus beta rho 2 D2 IR and R beta you can see rho 2 D2 upon A. So again beta this D2 these two finish A and A finish with party. So finally you can write here Q2 is equals to rho 2 K2 epsilon naught into V into A rho 1 D1 plus beta rho 2 D2. So finally we got this is charge Q1 and Q2. Beta they can also ask what is the boundary of charges appearing and boundary of the dielectric, right? So beta for that condition what you can write my dear, charge boundaries on the surface is, this is what my dear, charge boundary of the surface is Q2 minus Q1 upon A. Q2 minus Q1 upon A beta. So Q2 here just now we found rho 2 K2 epsilon naught V into A upon beta G rho 1 D1 plus rho 2 G2 Q1 here. Then beta you can say A Q1 minus Q2 beta. What's the Q2 here? Just now I found over here. So this is also minus here. This is also minus. So minus beta. What you can say Q1 minus plus beta. So this is the plus only. You can say rho 1 K1 epsilon naught V into A upon beta 01 D1 plus rho T D2. Rho 2 beta D2 here. So you can say bacha, you can take beta this K cancel, take common and just cancelling each other. Again here you can just take beta epsilon into V common, epsilon into V beta, what you can say common here, right? So yes beta ji. Finally beta Q1 minus Q2 upon A. Yes. So let us just further solve here. What you can see rho 2 K2 epsilon naught, right with charges. Okay. And this is VA. So AA beta A cancel S. So this is VA upon beta G rho 1 D1 plus rho 2 D2. Okay, it remains here minus only. Minus with G, you can see rho 1 K1 epsilon naught A cancel, yes, so simply we can say V only. This is V upon beta rho 1 d1 plus rho 2 d2. Further solve which I want to. So again you can take epsilon into V common. Epsilon net student, you can just take in common, my dear. So this is epsilon naught into V rho 2 k2 minus rho 1 k1 upon beta is rho 1 d1 plus rho 2 d2 upon beta. What you can say, this is rho 2 d2. So this is, you can see, boundary charge. This is what, my dear, you can see here, it's a boundary charge, right now. Okay, so this is the question here. Literally just now I solved the chapter. Literally I can say, my dear, it's not tough at all, but conceptually it's a good question. Conceptually beta, I can say it's a good questions, right? Okay, so have a look beta ji. Next question here. Have a look at chapter. Next question. Okay, so this is what, my dear, I can say it's a question here. Literally based on the some concept, that is capacitor only. The space between the plates of a parallel plate capacitor is filled up with non-homogeneous poorly conducting medium whose resistivity varies linearly in the directions of perpendicular to the plates. The ratio of maximum to minimum resistance is equals to when, if plate separation is D and DC voltage is applied, or you can say applied across the plates, find the volume density of charges between the plates. Okay, fine. So beta, you can say, as a, because I don't have time to just write entire questions. You have a parallel plate capacitor. Student, you have a parallel plate capacitor, right, my dear? Okay, this capacitor beta entire setup you can connect through DC source. You can connect through what, my dear? This is the DC source. Okay. Yes, beta. So now this is current I. This is current I. Beta, they mentioned the questions here. Beta ji, I can say this is the capacitor filled with poorly homogeneous conducting medium whose resistivity varies. What are students? Whose resistivity varies linearly in the directions perpendicular to the plates. Okay, let us say, students, D is the separation of the plate. D is what, my dear? Separation of the plate. Okay, this is, there is a linear density, means resistivity variation perpendicular to plates. So students, here you can write here easily, it's not tough at all. You have to just, anywhere they mention linear variation, so this is a very common way. You have to move x. Student, you have to move x and take element dx. Student, you have to move x and take element dx. Student, you have to move x and take element dx, right? This one beta, yes, you can keep in mind, my dear, right? Okay, fine, have a look. We have to move x and take element dx. Beta, resistivity here, let us suppose I'm calling for this part resistivity rho 1, this resistivity rho 2. Beta, I can say this part electric field. Students, I'm considering this is E1 and beta this part electric field students I'm considering E2. This is beta even I can say beta electric field for this part, E2 beta electric field for this part, right? A beta I forgot to just it's understood here. A is what you can say area of cross section. A is what my dear area of cross section here. So this is I, this is I beta, and this is V. Plus to minus, plus to minus. Okay. So beta first I'll write here dr value. You can say resistance for elemental section. So beta in solution dr is equals to rho L by A. Rho as a function of x, or you can say rho along x-axis into dx upon A. Rho L by A beta. This I use here formula of resistor. R is equals to rho L by A. Okay. Here I wanted to find I can say which dimension, the ratio of maximum to minimum resistivity. The ratio of maximum to minimum resistivity is equal to when? Okay. So now student I'm going to write here I can see total resistance. Total resistance, that is R is equals to dr. So limit beta 0 to d. This is rho plus n minus 1 into rho beta upon d into x. Yes, dx by A. If you are not able to just coordinate these all things, so you must revise student. I can see center of mass, rotation and gravitation. These all points, and I'm not covering over here, right? These all points beta I can say from there only. Means if you are not able to just coordinate these all points, so go and once revise first basics, and I can say fundamental of rotation and center of mass. It's a highly recommendation for those candidates who is failing to understand this one, right? So here beta I can see which I have taken here initial resistance resistivity is rho beta, final resistivity beta, this is considering n times of rho. This is what beta n times of rho are, right? So how I wrote these all things here I'm just writing once for your clarification. So rho beta at x, what you can write initially is this is the rho plus beta n minus 1 into rho upon d into x. Rho as a function of x, right? So d rho beta, what you can say, this is remain 0 here, just differentiate once. So d rho beta you can get n minus 1 into beta rho upon d into dx. This is beta I can say 0. This is what my d n minus 1 into rho upon d into beta. This is what dx. So these all things beta just fit over there here. Already I put it. Now it just differentiate here. Integrate picture body. Integrate once. So if I'll integrate picture, so this is rho beta, and what will get d by a. So total resistance. This is what made here. Rho d upon a plus n minus 1 rho d beta. Just see here only here. There are what I'm doing everything from here only. It's a d square here. So x square by 2. So dt cancel here. So you can say this is what 2a. So finally beta just solve here. You can just take LCM bachcha party. So you will get eta means n, not eta here. It's n. Student, it's you can write बच्चा जी this is n plus 1 into beta. This is rho d upon beta g 2a, right? Okay, so finally beta we got the things here. I can say total resistance बच्चा party. But BB is to find volume density of charge between the plates. Volume density of charge between the plates. Okay, so beta I can say for this condition here, just use beta. I can say Gauss law. Then beta will get easily here. So this is what is called Gauss law. According to Gauss law here, this flux is equals to beta Q enclosed, no? Flux is equals to beta what you can say Q enclosed upon epsilon naught. So student, according to Gauss law, beta, I can write E2 into A minus beta G E1 into A, which is equals to beta. Just tell me, rho at a distance x into A flux you can write here. So this is A into beta dx. This is right here in terms of sigma, basically sigma of x into A into dx upon beta epsilon naught. So E2 A beta I can say cancel everywhere, and electric field beta I can write here, that is rho 2 minus rho 1 student I by A, which is equals to sigma x into dx upon beta epsilon naught. So this is n minus 1 upon d rho beta dx. Just further solve here. No one is available here till now. I'm also going to stop the live session, right? Just beta, listen here. Just I'll complete these questions. Sigma x into rho upon beta epsilon naught. So what we have to find here? Volume charge density. Sigma x beta will get from here only here, right? You can say this dx finish. Now beta. So finally here we'll get sigma as surface charge density. This is twice epsilon naught v eta minus 1 upon, not eta here, n, it's n bacha, n plus 1 into d square. Now beta I'm going to stop live session here. Yes, so beta this is all about your 2D question here. I couldn't like I have many questions still, like EMI, magnetism, like beta current electricity. I'll do beta these all things next class.